The broadcast is now starting. All attendees are in listen-only mode.
All right, everyone. I'd like to welcome you back to another KevCAM night class tonight. Tonight, have Tim Micah helping out with any questions or concerns that come along the way. Tim, are you with us?
Yep. Good evening, everybody.
And of course, can't forget Greg Payton to make sure I'm not forgetting anything for you guys. Greg, are you with us?
Good evening.
All right, excellent. So we got everybody here. I do see a couple new names in here, so I'll go just through quick housekeeping. We are using GoToWebinar, obviously, but everybody is on mute just to eliminate any background noise. If you guys do have a question, there is a questions pane for you. Go ahead and type those questions in there for you. These classes are solely dedicated for you guys, so definitely a question arises, let us know, and Tim will read it off, and we'll get those questions addressed right away. Feel free to ask them at any one point in time. Very laid back class, as you'll soon see. But if you guys do want to see a previous episode of the night class, you can come and go to the SolidCAM website, hover over webinars and click on KevCAM, and you can click on the Missed the Last Class, as well as if you go over to YouTube, type in SolidCAM University, you'll see all the videos that we have here as well. So with that being said, we are going to get the ball rolling tonight with HSS Linear. So last week we talked about HSS Constant Z, and as we were going through that, we recommended that anytime you're doing surfacing using Constant Z, to try to keep those angles between 45 and 90 degrees. That's where you're going to get your best results in the Constant Z, because the tool path is constantly stepping down in the Z axis. Well, now today we're going to be showing is linear, and linear is going to be the exact opposite of the Constant Z. So it's based off of a step over versus a step down. So where that really comes in handy for you guys is on a more flat area. So like we said, 0 to 45 degrees. And so I got a couple different parts here I want to show you guys. Actually, let's start with a different one here. I'll bring back one other one. Nope, not that one. Go browse recent so I can see my parts here. So this is the part that we covered last week, or part of the part that we covered last week, and we both Greg and I showed you guys how to attack the Constant Z, and we can turn on the toolpath by showing it right here. So today we are going to be covering the linear, and for those of you that were here last week, it might be a little bit of repeat, but I kind of want to go through what everything does in there again for you guys. So first thing first is you'll come up and grab your HSS, and you can hit the drop down. Oh no. So I'm having all kinds of graphics issues with the GoToMeeting. I think it just bombed out my SolidCAM here. 1 second.
And to this point, Kevin, everything's been coming across pretty well there with the graphics.
Okay.
Right before the meeting started, it was kind of flashing, but now we're been seeing pretty decent graphics. But
okay, perfect.
That we started, and we'll jump back in.
I tried changing the resolution for you guys to see it a little bit better and see if that's where we're having our slow performance, but something to do with GoToMeeting, just like slowing down my computer. All right, 1 second here. Okay. So I think we're back here. So we'll go ahead and do HSS. And like I said, we'll switch it from, well, it's actually set on linear right now, but so we were coming here before and getting Constant Z. Is my screen updating?
It's still stuck on that screen when you came back to SolidWorks. There we go. Now
Okay.
It just updated.
Okay,
now you're going. Perfect.
All right, sorry about the stuff here, but the great joys of showing live. All right, so last week, like I said, we covered the constant Z. Now we're gonna go for the linear. Now, pretty much everything that you guys are gonna see in here with the HSS is gonna be same all the way through, just some minor stuff that has been added or deleted in there. So for our geometry, what surfaces do we wanna cut? So I'll go ahead and hit new, and I wanna tell it I would like to cut these surfaces here. And kind of like we talked last week, so we can do full avoid at exact edges, full and start at the exact edges, or limit cuts by 1 or 2 points. And we'll kind of go over those in a little bit, because I know Greg is going to drill me on those. So I'll show you guys that. Right here, our drive surface offset. If we're cutting into this surface here, and we'd like to see this going through and cutting maybe a little bit deeper, or maybe you ran a pass through and you need to take a little bit more material out, we can put a negative offset in there, so a cut deeper into the material, or a positive at that point. Now, defined by angle, let's throw a tool in here real quick, and I'll show you what the defined by angle is going to do for us here. All right, so we'll go ahead and save and calculate. So right now, we are going at 0 degrees along with the x-axis. So right now we're set to 0 in there. Well, I think it's along, yeah, with the x-axis. So now what you guys can do is, if you're trying to achieve maybe like a 45 degree in there, the tool path will automatically adapt to that 45 degrees. So we're covering the most amount of area. The one I really like to use, especially with linear, and if I'm trying to follow a certain curvature, is I can come in here and do line. So by picking line, it's going to ask me, all right, where do I want my start point for that to be? So we'll tell it that's my start point right there. And my end point is going to be right there. Go ahead and accept that. And now, if we do save and calculate, the tool path will follow exactly along with that curvature there. So you can see we're getting a nice Z or linear lines going back and forth all the way through. Now, like what we talked about last week, on this more vertical walls, we're not going to get as nice of a finish versus this more flat area right here. But we'll kind of go through and show the differences here. So drive surface offset, we can do defined by angle. The avoid surface edges, so if we go right up to the edge, we should see our tool path bump up right towards the top now. So that tool is going to come right on the exact edge. And now where it comes in handy is if we go limit cuts by 1 or 2 points, I can tell it that, all right, from, basically right here, go to data, from right there to right there, I want to trim off all the tool path outside that boundary. So now if we do save and calculate, it eliminates all that higher degree angle of engagement. So what we could do is we could do a constant Z for this upper half here, and then do our linear for more of this flat area right here. So that's kind of a nice way to fine tune your tool path, as well as we can do a 2D boundary at that point too, but that would involve creating a sketch or just manually going around and sketching something in there, or grabbing geometry that's already on the part. So tool, we know how to do that. Levels, by default, it is going to be set to automatic, so it's just going to go automatically what it thinks it needs to do. You do have the option in here to do plane, and since we are working off a plane, that's what it should be going to. But this is all your clearance data right here. Now, usually when we've been covering profile and pocket. I'm machining the levels is basically how deep we want to go. Levels here is all about your clearance. Now, toolpath parameters. If you think about toolpath parameters, think of the step over as how pretty of a finish are you looking for, or what kind of surface callout are we looking for in there. Now, for those of you that were watching last week, I told you leave this at 50 thou, because by default it's going to be 50 thou. Get everything cleaned up first and then tighten this down to where you need to be. So what I mean get everything kind of cleaned up right now is we have a lot of jumping up and down. We're doing a zigzag pass right now. We're doing a zigzag pass right now. We don't need to do any extensions, but I have a lot of jump up and jump down here with these red lines. But if we turn back the dial just a little bit here, I always get ahead of myself. So the surface quality right here is, the tolerance of that surface. So with HSS, it is all based off of the surface inerb itself. Where if we do a HSM, it's all based off of a facets, which is basically little tiny triangles. So how accurate do we want to be on that surface? So by default, it is going to be set to 8/10. You can dial it down to whatever number that you would like to specify in there, or we can just turn off the checkbox right here and use the slide bar right here. Okay. Chaining tolerance is basically adding more additional data points that are in there. This is one that not too often that you'll have to change. And, kind of like I said last week, a lot of the default values in here are already pretty well set. So there's not a whole lot that we have to do in here, and it's going to look like I'm programming a lot for this part, but it's more just kind of explain of what everything does. So if you think about it, all you really need to do for this part is grab our geometry, and we told it we wanted to follow that certain angle. We grabbed our tool and we save and calculate, which got us our path that's right here. But if you want, we can do zigzag, one way, and spiral. Now, if you guys are not seeing spiral in here, or if you're grabbing this drop down and you're only seeing linear and constant Z, that means you have HSS limited. And at that point, call your account manager and tell him you want to go to full HSS. You can even call Tim; he'll take it for you.
Yeah, the constancy and linear are something that we throw into the more basic licenses just to give people a chance to do this surface work without having to spend a lot of money for the other options that are all available, showing up in that list there Kevin's got.
Yeah, I like to call it the teaser. We'll give you some 3D path to tease you with it, but like I said last week, there are some functionalities that you will not be able to do that I'm showing in here if you are running the Express version of HSS. Okay, so going farther down, cut order. How do we want to approach it? Do we want to do just a standard? Because we told it that we wanted to start over here and end over here, and it's going to do a zigzag pattern that way. Do we want to go from the center and work our way outside to work our way in? If you guys are cutting multiple surfaces, so if we are cutting this over here and cutting this over here, what it will do is it will try to blend them together and do it all as one cut. Well, obviously we want to focus more on the one part, and then once it's done with that one part, we like to switch over to the other part. That's where we can tell it right here. So lanes, it's going to try to do everything at one, where regions is going to regionalize it and do everything on this surface here, then move over to this surface over here, and then move on to the next surface. So, as well as the flip the step over. So right now, and for those of you guys that don't know, if you're looking for a start point where your toolpath is starting here, the little red dot right here is a good indication of that. So if we wanted to start on the opposite direction, we can do the flip step over. And now it's starting down here and it's going to work its way up. So good way to switch around your toolpath. Now modify, You guys do have a couple different options in here. To be honest with you, these three up here, I never touch. You know, Greg or Tim, do you guys ever change up this surface edge emerge distance?
I have not.
There you go. But the 3D tool comp, it does get asked by a couple of customers, so that option is there for you, as well as smoothing. But the one that you are going to use quite a bit is the extend trim. So we can extend our tool path beyond our certain area. So if I wanted to extend my tool path on the start, and I'm going to go through each one of these here. So the start and end, I'm going to tell it I want it to extend it by 100% of the tool. And now you can see, if I get a straight down view, that we've extended our tool past our physical drive surface. Okay. Now that is your start and end. So it's going to bring it more over here and here. Now, if we wanted to go this way, and this one gets a little confusing. So even for myself, I'll have to kind of play with these a little bit because of side extensions. So if we wanted to extend it out on the side, we can do on the start side. I don't want to worry about the end side, but I just want to do the start. Now we should have our toolpath extend out this way as well. So there's no need to draw a surface in there. It will follow along the surface curvature as specified. Now, tool control. Now we talked about, you know, gouging into our part, going a little bit deeper in the levels area. I kind of like to use this one. Think of this as your levels. All right, so I want, you know, maybe I want to go a little bit deeper, the entire tool path. I would just want to drop down everything. And if we had this tool path involved right here, if we did a drive surface offset, it would push everything in there. Where if we do the shift right here, we're basically shifting the tool path down. And this is going to kind of come in handy if you guys are using more of like a chamfer cutter and you want to shift that tool down and over. So we're not working on the tip of that chamfer tool. We're working, we can work more on the side. And kind of like what we talked about last week, we have several different tool contact points, auto, at center, radius, and front, so we can control it. Where the auto is automatically going to adjust that ball end mill or the bull nose end mill or even the flat end mill on what we're cutting there. Now, in our link page, we're going to make this tool path look a whole lot prettier. So we're wasting a ton of time going up and down and moving them back and across, up and down. So what we can do to clean up that is go to our links and our links tab. So right now, if we have any gap, and I'll show this on the next part, but if we have any gap in our surface, we can fill that gap in just by telling it to go over that surface without having to do a surface fill. You know, like I said, I'll show you that on the next part here. But links between slices. So each one of these lines is considered a slice. So what we can do is we can tell it that instead of going up to the clearance area, I'm going to use my favorite here. You see we have a whole slew of different ones in here, but my go-to here is the blend spline. So now let's just see what we did. Save and calculate. So now when we zoom in here, we're doing a nice arc going from one slice to the next. So we're not wasting that time going up and down, and we're not seeing those sharp corners in there. And for those of you guys that are really paying attention here, we can actually see we have a sharp corner here. Well, that's considered a small move. So we told it to do a direct. So if we want those smaller moves to do a nice arc as well, as we can do a blend spline as well. So now we got those nice, pretty smooth. We won't get any machine jerkiness going on or anything like that. Now, for each one of those, we have a lead in and lead out option as well. So right now, since we're way off our surface, we don't need it, but the option is there to do a lead in and a lead out for our small moves, as well as a lead in and lead out for our large moves. Now, if we just go back to the approach retract tab here, this is basically our entry and our exit right here. So when we were talking about profile operation in the links tab, that was our lead in and lead out. That's exactly what we're doing right here. So we can tell it to use a lead in and we can tell it to use a lead out, but you can see I don't have any options of what to use there. So just go down one level here and it's going to be our default lead in and lead out. So right now, by default, it's going to do a automatic arc. Let's just see what that looks like here. So we're arcing down into the material and start getting into our material as well as arcing off. But as you can see, maybe our lead out is something we want to change it up a little bit. So we can switch that over to maybe do a reverse tangent arc. So now we're arcing away from the material. Actually, we'll just do a tangent arc. So now we're coming out and arcing away from the material that way. So there is a lot of different options in here. We can do like a horizontal tangent arc. And now it's basically, let's really rotate my part here, finishing off the cut, and it's slowly start moving up in Z at the same time as that end mill has moved off the material there. So, okay, gouge check. HSS will gouge your part. And I can just see from what we have right here, we're fine. We don't have to worry about gouging. But there is going to come that time where HSS is gouging into your part. And we talked more about it last week, but we can turn that on. And like I talked about last week, is I like to turn on my gouge check just for my drive surfaces for my gouge 1. So what I'm doing is I'm telling it I do not want it to gouge that drive surface with the tool shaft or the tool tip. And once it does, it will retract the tool. I can also turn on my holder or my arbor if I'm worried about shanking out. And then what I like to do for my gouge 2 is enable that, and we'll do our check surfaces. Now the check surfaces, think of as the surfaces that you do not want tool path on. So if we go to new, I can click each individual surface that I want, or I can just click on all adjacent and it will pick up all the adjacent surfaces to my drive. And the nice thing about that is now I can tell it that, you know, instead of doing a retract tool, trim and relink the tool when it hits that surface, and I can also put a tolerance and or a stock to leave in there. So maybe if it's hitting right here and I have a 45-degree surface, to leave, you know, 5 thou in there for a different tool path to come in there. So you guys got a ton of control using HSS. And personally, I think HSS is one of my favorite tool paths we have in here. For those of you guys that are looking at the future of getting a 5-axis machine, HSS and 5-axis are identical. So if you guys are comfortable with HSS, 5-axis is going to come so much easier for you. And we can keep adding gouges in here as well. So gouge 3, maybe we want to do a check surface against a bolt, and we want to, you know, that we want to clear that bolt by 10 thou in there. We can put that in there as well. So that is our gouge. Clearance data here. We can set up clearance data for our holder, basically our safety. So if it gets within 100 thou of the holder, the arbor, tool shaft, and the angularity limit there, as well as our roughing and more. So maybe we would want to do multiple passes. We can come in here and let's just do it. And let's say, well, this one is going to be more for side step, kind of like a clear offset, so it's going to move it more out. Now, if we wanted to come down on the material, we won't use the multi-passes. We would use our depth cuts. And let's just do 10 at a spacing of 100 thou. Now, basically what it's going to do is it's going to take my tool path and just offset it up by 10 thou. So the exact same tool path, I just offset it up by 100 thou. So each pass is doing 100 thou there. Now, this comes in real handy when we're roughing out, but let's say I have a lot more material over in one area and not the other area. So I'm going to be doing a lot of air cutting right now. So what I can do in here is go to our stock definition, turn on, tell it to avoid all air cuts. And what it's going to do is it's going to look at the stock that's there built off our STL model, and it's going to eliminate any of those air cuts. So now, basically, I can calculate this. You can see we're back to our same tool path because there is no stock. Well, there's stock there, but there's not more than 100 thou worth of stock. So that feature does come in handy, and I don't see a lot of people using that, but that option is there for you guys.
Hey, Kevin, can you adjust your 3D eye machining roughing pass just to leave, let's say, 1/8 of an inch on those surfaces?
Absolutely. All right, so go to our technology.
I think this will give a better representation of exactly what that haircuts is doing.
All right, so now what I'm going to do is I'm just going to here. And what I want to show you guys is how much material that we have left over now. So if I go to Solid Verify here. Up all my Okay, so you can see we have a ton of material here, all the way around. That's in there. So now, if we go back into this operation, we'll go to our roughing and more. Depth cuts are set up there.
Yeah, I think if you just toggle the tool path for the eye machining, you'll be able to see what it's doing now.
So now we can see, even though I told it that I wanted to cut 10 passes in here, it eliminated it down to 3 passes here because it knew the material that was left over. So like I said, it's real powerful. Like I said, I don't see a whole lot of people using it, and when I show it, wow, that works pretty slick, but it does work very well with that stock definition in there. So you're not going to get any of that air cutting going on there.
Well, what's also pretty neat is if you look at the passes going up that surface, you can see where it's hitting those stair steps as well on the roughing passes.
Right here.
Yeah, can you turn on the updated stock out of the cam tree, Kevin? There we go. And so, yeah, this is a good representation of what stock is there. So if we kind of scroll this around, you'll be able to see those passes only cutting where those stair steps are. And if it sees a gap in it, then it just moves on to the next one.
Absolutely. Pretty cool technology. Now, one thing that I think I forgot last week, we started getting on this road and then got the wow factor going, but I didn't cover the plunging or the morphing pocket or the sorting or the mirror. So the rotate and translate is the exact same thing as what you guys have used in the past with using the transform. So we got before HSS could not use the transform functionality. Well, in the newer versions you can now, but so that's going to cover your translated and rotated surfaces as well as your mirroring. Now the plunging is going to be set up if we wanted to come in there and do a plunging pattern with like a spade bit or end mill and do a plunging pattern that way. I think we talked about the plunging pattern inside of pocketing, but you're going to get the kind of the same results here with the plunge pattern going in there. So it's more set up as a roughing strategy. Then morph pocket is not one that I like to use a whole lot. I'd rather see you guys use iMachining for this, but you guys do have the ability to go in there and do if you're doing kind of a close pocket, to do a morphing, and we can tell it what step overs we want in there as well. And then sorting, just how we want to sort out our chains as it's going through. And that is it. So any questions on this part before we move to our next part? And I can't even see the questions, so one of you guys will have to help me out there.
Yep. There's nothing there at this point. And Greg, that's a good point, what you were having Kevin show there with, as we're working up those stairs, the offsets that are happening in the HSS toolpath, there'll be too close, and then there'll be kind of a gap as it's working up those 3D iMachine, or those the iMachining stair steps there. So it's kind of a cool thing to see there.
Yeah.
But no additional questions.
Before we leave this part, can you turn off the roughing and more and the limit by points? Basically, I want to see the tool path along that entire surface using linear, and then compare it side by side with the tool path with constant Z. Because this sample part especially does a good job of showing it what the differences are between the two, even though they're very similar tool paths.
And let me go back to the iMachine here and put it back to where we had it. Oops, turn that. Oops, nope, turn that off. I think I had this. Give it a second here. All right, turn off our updated stock, and let's go ahead and simulate this. Actually, no, what we need to do here is turn that off. In our HSS constant Z, we had a 10th step over, and that was, so that one thing I forgot to cover here is the last thing, like I was telling you guys to do, is come in here and then set your step over, because like we were talking last week, you set a small step over there, you can't see what those lines are doing. So now I have everything nice and spaced out. I can see what that tool path is doing now. Got my gouge, everything all set in there. So now I can come in here and fine tune my surface that we're looking for here. And now if we simulate this, give it a second here. It's cold in Minnesota today, that's why it's taking longer.
Need to put a heat lamp out there for those squirrels.
Yeah. Okay, so let's actually play this through with no color, so you can kind of see an exact side-by-side comparison. So over here, and that constant Z, like we're talking about, that more vertical wall is going to have a much nicer finish with using constant Z versus linear. And vice versa, we have a more flat area right here, same step over. Well, actually, we had a 10 thou step over here. With over here, we had a step down of 10 thou, and see a much rougher of a step down here versus over here. So this is really where it shines. And we'll get into different strategies where you don't have to worry about doing the two different tool paths in there, but you can really see the difference of the different tool path strategies based off of one is linear and one is constant Z for you guys.
Now, why don't you exit the simulation, Kevin, and let's just look at the wireframe toolpath on the models themselves, and then just do like a straight-on view from the front. Okay,
like
or yeah, from the top as well. So looking at the top down, you can see that on the linear, it's constant the whole way through. Like each slice is exactly the same. Whereas with constant Z, you can see it changing.
Yep. And then if we go front, now we got the exact opposite. So much more spread out gaps here because we're telling it to do a step over and not step down, where over here we're telling it to do a constant step down. So we got nice even lines going all the way through. So we're trying to look at.
Yeah, just showing off the differences between the two paths, because I mean, from a bird's eye view, they look very similar, and you're going to be like, oh, why pick one over the other?
Yeah.
But I think this does a good job of explaining to people what scenarios they should be using these operations in.
Yeah, and absolutely, and we'll get into actually it'll be next year now. Like HSM, you can set up actually a combined constant Z with linear, so we can tell it that all the linear passes, which are going to be from 0 to 45 degrees, I want to use a linear toolpath, and from 40 degrees to 90 degrees, I want it to do a constant Z pass. But we'll show that later on. All right, so let's hop out of here real quick. And do this part right here. And for any of those, I did have actually 2 people request the parts from last week's. If you guys want those parts, let me know, and I can send those over to you via email, and can share them with you that way. Okay, so what I want to machine in here is this top curvature of this face here. And we can see that it's not a very high angle, so this is where our linear is really going to shine. So we'll go ahead and do our HSS here, and we're set to linear. So what do I want to cut? I want to cut this area, and you can see we have a pretty large gap in here. Now there is no need to go into your SolidWorks tools and fill up that surface. HSS will take care of that for you. So got our geometry. We'll go ahead and grab a tool here. And grab this ball end mill here. Levels, I'm just going to leave. Toolpath parameters, like I said, keep it large. And just hit save and calculate. Start building it like we talked about last week. Think of HSS as a building block. Make a couple changes, save and calculate. So now we can see, well, one, we have a lot of jump up and jump downs between our slices. So let's go to our links. And our slices, instead of going to clearance, we're going to do a a blend spline. So now that took care of all the outside edge ones. If I just want to double check, I can kind of zoom in and see it. I can see a couple smaller ones here. So just to be on the safe side, we'll just do a blend spline for everything. So now every single one, we got a nice arc going through there. But like we were talking earlier, we have a gap in our surface. So with that small gap, it will go direct, but I have a large gap here. So what I want to do is tell it to do follow surface, and it will treat it like that hole isn't even there, just basically skipping right over the top. And like I said, I didn't have to do a fill surface or anything along that lines. It's just looking at it as that curvature just keeps going all the way through. So like I said, there's no need to have to go in there and patch up holes or anything along that lines, and it will do very large gaps, as you can see right here. So now we have our tool path set. Everything looks good. I'm happy with my start point, my end point. I like the direction that it's going. So my very last thing that I'm going to do is go to my toolpath parameters, and this part it's in metric here. So we'll do a 0.01. .01 metric must be really small. I didn't think about that before I typed it in.
Yeah, it's about 4th out, right?
I don't know.
Yeah.
Okay. And this
Where's
is
Mark?
What's that? Yeah, we need Mark here. So, like I was saying before, this is the thing that you want to do last. One, because with that 4th out step over, it took a little bit longer to calculate. But two, I can't see what's going on unless I come in here and zoom way in. Then I can see my lines. But you know, that's why I like to keep that step over large. And the very last thing I'm going to do is change that up. So now if we go to our simulate, and we can do our solid verify here. Actually,
Now, one thing to keep in mind is if you are tightening up that step over as the last step, definitely be aware of the links selection, because if you're closing up the gaps between slices, that could change some things from a large gap to a small gap, and thereby change your selection. So yeah, if you do tighten things up, just take a look at your links.
Yep.
And
yep.
make sure they're still doing what you want.
And one thing I'm noticing here is, since I do have additional stock on there, I'm not going all the way to the edge. So this is going to be that great spot to come in there. We'll hop out of our simulation here. And one thing I'm going to do is change that to
.01 is actually 4/10.
Yeah.
4th out.
Yeah, that's what I was thinking. I was looking at that toolpath. I'm like, man, that's really tiny.
Yeah.
All right, so now we're going to do a modify, extend, trim, and I'm going to do it all the way around. So I'm going to tell it I want 100% on my start, 100% on my end, as well as 100% on my side of my start and my end. So now, if we save and calculate here, now you can see my toolpath as it's been extended out significantly here. And I probably didn't have to go that far. But now you can see our toolpath is going right to the edge, going all the way through. Now, what we could do too, I'm just kind of thinking out loud here, is if we extended, maybe if we did 200%, I'm going to save and calculate this so we can just see what the path looks like here. So we're way over coverage for the most part here. Now, if I didn't want it to cut any air moves, I could go to my stock definition, turn that on, and it's going to look at our stock, trim up our tool path. Oh, didn't like my stock definition there. I might not have even stock on here. That could be why. Might have just taken the 3D model and expanded it. What I was thinking we could do is just extend it way past and then just trim it up that way, but looks like it's not liking that. But let's try. Just looking here at what we have for stock. Yeah, it's not seeing it. You guys kind of see where I'm going here. Just put this back. Oh, we can to 100%. There we go. There was one other thing I was going to show you guys in here. I can't remember what it was. Oh, so right here, let's say we want to go down 1 millimeter. So basically what's going to be happening here is we're shifting our tool path all down by that 1 millimeter. Now, in this particular case, I don't think it would quite qualify. It'd be more for doing that chamfer around the outside, and we'll actually do that in one of the next classes coming up. But if you guys are looking to shift down your tool path in the part, definitely come to your geometry and do a drive surface offset of, we can do 0.1 millimeter. It should look identical. And there we go. Getting stumped here. Why am I not seeing? Go to Solid Verify here. Yep. Okay, so we are cutting. So you can see we're actually gouging into our part here because we did that drive surface offset. So like I said, if you cut a part and we need to just go a little bit deeper, or maybe on your next part you want to go a little bit shallower, this is where it's going to come in handy for you guys. So
now let's take a look at the differences between those. Can you do a save and copy on this toolpath? And then change this one from the drive surface offset to the axial shift.
it's going to be
okay. I'm going to ask you to change the tool. Do a copy of the tool. That way we can change the color, because I think blue on blue is going to be too hard to see.
Oh, you can't see it?
All
right. So it should technically be the exact same.
No, it's going to be a little bit different.
Trying to get the best view for you guys.
Yeah, it's going to be hard to see.
Because
the drive surface offset is going to be based off of the surface normal. Whereas the axial shift is going down in Z.
Gotcha. If you went with a larger different 0.1, make that a bigger number, so they vary.
And let's go like this.
I mean, it may be negligible for this surface.
Yeah. It's hard for me to see, but yeah, like I said, we'll get into this, the actual shift, when we start doing 3D chamfers, because that's a big thing that I want to cover with you guys as well, and probably be on this exact same part. But for if you guys are just looking to basically make that, like if you're doing a mold and you need to go a little bit deeper or shallower, I would definitely go to your geometry page and do a drive surface offset at that point. Because if we're going more at a higher angle rate is where I think we would see the difference in that actual Z shift right there versus the drive surface. So, but any questions? You got any more?
I've got one if you're feeling up to it.
I was waiting for it.
I want you to fill that hole with a surface, a SolidWorks surface.
So to go do our fill, right click on it. I'm going to do edit part. And we are going to go to our surface tab here. And we will do a filled surface. Okay.
Beautiful.
And now, do you want me to do that as HSS again?
Yeah, HSS again. But I mean, we showed off the ease of use for clearing that gap using the links and having it just follow that surface. But when it follows that surface, it's going to be doing that at the normal cut speed. So depending on what materials you're cutting, how slow that's going, you're going to find yourself with a lot of wasted time going over a large gap like that. So I was wondering if you can show off the feed control zones in the tool settings. Because I don't believe we've gone over that yet.
Excuse me. No, we haven't. Okay, so our feed control zone, let's say we want it in here. We'll chain the section. On that one, I want it to do an inside feed of 200% versus the outside of that circle is going to be set to 100%. So that's exactly what Greg is talking about here. Is basically what we're going to be doing is as we're feeding, let me get rid of this toolpath parameters, modify, I'll turn off our extensions here. As that tool is hitting that center, it will actually feed up through that area there. So let's just see it in motion here.
So a little more work to get it to that point, but if time is a factor for you guys, then it'll definitely help out in speeding up this tool path across those large gaps.
So right now we're at 1,000 millimeters, and we should start seeing this feed rate start bouncing up and down here. So you can see it just real quickly there. And we'll get it to the middle here, and I'll single step it for you guys so you can see the. Tim wanted such a small step over. Okay, so now if we go into single step mode, you can see that we're over that hole right now. But we also are going a much faster feed rate versus now as we get onto our current drive surface, our feed rate is going to drop right down to that 1,000 millimeters here. So it's a great way to really control your feed as it's going through that cut, and we're not wasting time, over doing a standard feed rate through there. Now, if this is something that if you guys are only doing one part or two parts, I wouldn't bother wasting the time doing it. But if you guys are running real high production, this will definitely be a time savings for you, especially the larger the gap that you guys have there, the more time savings you guys will have there. So like I said, we can see it hit 1,000. As soon as it hits to our open spot right there, it's switched over to 2,000. And then back down to 1,000 right as it's getting back into the material. So yeah, great point, Greg. I totally forgot about that. So, all right, Greg, what's the next zinger?
That's it for right now.
Man.
Yeah, you brought up the part, and I was like, oh, this would be perfect to show it off.
Yep. And do we have any questions from our customers at all?
Nothing coming in, so you guys are quiet.
Well, if you guys do have questions, my email address is in the right by my name in the GoToWebinar. Definitely shoot those over to me via email. Like I said, if you guys would like these parts as well, I can zip them up and send them over to you. For those of you guys that are watching it on YouTube at a later date, my email address is below in the description of the video. So definitely feel free to reach out to us. Here to help out in any way we can for you guys. And like I said, these classes are solely dedicated for you guys. So if there's something that you want to see or change up in there, just let us know what we can do for you guys.
And Kevin, great job again, and Greg as well. I mean, a lot of good points and things to point out in the software there. You guys hit on a lot of interesting topics there.
Yep, absolutely. And coming up, it should be sent out to you guys probably tomorrow, the schedule going forward. We're going to have a little bit of break in there for the Christmas and New Year's, but we are basically going to keep working our way down the list. So we'll head over to hatch next, and then we'll cover parallel to curves and parallel to surface, as well as perpendicular to curve. And those 4 classes will be coming up on the website. And like I said, if you guys head over to, I'm just gonna go to solidcam.com. You have to make sure that you have the American flag up on top. Come over to webinars, come down to KevCAM Night School, and this is where you can register. And like I said, tomorrow you'll see all the new class lineups in there for you guys. So definitely come there and register. So, all right. Well, with that being said, I'd like to thank everyone for attending the night class. And anything else comes up along the way, let us know how we can help you guys out. And we will talk to you guys soon. All right. Thanks, everyone.
Good evening.